Hello. In the last class, would start the class. In the last class, we started seeing about C functions. We have seen about C underscore column underscore table, which we've been using it to read data from a table. Same thing we have seen about C underscore join underscore view or C underscore overlap underscore view and C underscore calc underscore view. Next one is about C underscore projection. So basically, projection is about implementing your where clause and projecting only certain columns of a table. Two things you can do with projection. One is, let's say your temporary table has got lots of columns. You just want to project only certain columns of that and also apply where clause on it. Then you would you use it to apply your C underscore projection function. If you see this here, I've created a procedure for the C projection. So first what I'm trying to do is I'm trying to use this C function, C underscore column underscore table. And I'm reading all the columns from this table and all the rows and collecting the data into this out tab. Next, by using this function C underscore projection, I'm referring to this, the syntax would be the table name, comma, and the list of columns what you would like to project. So I just want to project only these three columns, customer ID, company name and country name, and comma, and I have a where clause to be applied. I say where my customer ID is less than 5. So I'm applying where clause, and actually the out tab has got lots of columns, 8 columns, but I'm just projecting only 3 columns of it from this table and then just printing this result. So this is the purpose of C projection. And when I call this, you just get to see that data. I think this table has got no data, or STS dim customer 1. There is data, but there's nothing which is less than 5. So what I will do is I will say less than 10, and let me say this is 01. So let's activate this. So I'm going to call this. So it's going to print me which are less than 10, which is 5, 6, 7, 8, 9. Yeah. So like this, we can use this C function, C underscore projection. Next one about C underscore join. So we use the C underscore join function when you want to join two table sets or two result sets. So I'm using this function C underscore column table again and reading data from table 1. I don't have this table. So I'm referring to cubic schema here. I've got two tables. One is STS dim customer. Okay. Then I'm referring to another table called fact customer. So I have the customer table and I've got the fact table. I would like to join the customer table and the fact order table based on this customer ID. Yeah. So what I'll do is C underscore column underscore table. First I'm reading the columns from table 1, STS dim customer, but I'm just reading only two columns, customer ID and customer name. I can either use C projection to filter out the columns, or within the C column table I can specify the columns what I would like to read. Same way I'm collecting the result set into tab 1, which is temporary table. Then I'm filling this tab 2 from another table, fat customer order, from customer ID and net sales. Then I would like to join the result set of table 1 and table 2 by using that customer ID column. Then this is the syntax. Tab 3 is equal to C underscore join content of tab 1, which is the left table, then comma the second table content of tab 2, and what is the common join column, which is customer ID. Then after the join is performed, what columns do you want to project? I would like to project customer ID, company name and net sales after join is done on customer ID. And by using C join, we can only join two tables. If you want to join three, first we have to use C join, join table 1 and table 2. Then again use C join, join the result of table 3 with another table. That's how we have to do. So let me just take this. So C underscore join, by default it is an inner join. You see this customer ID is being repeated because we have not yet aggregated the data, but this is just a join. We have joined two result sets from two different tables. So same way, if you want to go with left outer, then we have other functions. C underscore left outer underscore C underscore right outer join. It's pretty much same. If you want left, by default, it C join is inner join. If you want left, you will say left outer underscore join. And the first table is considered to be the left table, and the second table is considered to be the right table. Then the functionality will differ, but the join concept will be left outer join. So when you say left outer, the operation, it's a join, but C underscore join is inner join, and when you explicitly use operation C underscore left underscore outer underscore join, it performs a left outer join. Same way if you use right, it performs a right outer join. Next, aggregation. You see this result. When you look at this result, it is in fact not aggregating the records. We do sum of amount and group by so and so. Look at this. I see same customer, same company name being repeated for net sales, but I want this net sales to be aggregated with respect to customer ID and name. Yeah. Then we can use this operation. Then we get into next operation called C underscore aggregation. I'm trying to do the same. I'm trying to read data from customer table, fact table, then I'm performing a join. Then table 3 is going to hold multiple entries for the same customer. But now what I would like to aggregate my net sales based on the customer ID. Like it's like say sum of net sales grouped by customer ID and company name. So for that, when I want to execute that group by function with some aggregation functions, then I use the C function, C underscore aggregation, refer to the content of tab 3. Then next, what aggregation do you want to do? I would like to aggregate this column, sum of net sales as sales, comma, you want this aggregation to be grouped by what? Grouped by customer ID and company name. This is the syntax. So from this table, I want this column to be aggregated, and with what grouping? Yeah? And then I'm just printing the result of tab 4. This, I don't have this tables. line number 7. Let's perform. Now when I say call this procedure, it's got a same join results and it's going to aggregate now. Now do you see only one record for this customer 109? It means the net sales have been aggregated. So that is where we can use the function C and underscore aggregation when you want to aggregate the record with some aggregation function group by class here. Next one is union all. Yeah. So basically, union all, like you let's say you have two result sets, result set 1 and result set 2. You would like combine both the result sets and then project it. Then it's union. For example, I have one result set which is giving me sales of year 2010. I have one more result set which is giving me sales of 2011 and so on, so 12, 13. So in this case, I would like not join, I would like to combine all the result sets and then project as one. So then we can use union operator. Now here look at this, I'm just using reading the data from this table just to simulate. I'm just reading data from this table. Then I'm just saying less than 10 as one set. I'm using C projection, formatting one table with the customer IDs less than 10. Another table I'm forming with customer ID greater than 110. And then I would like to take the result set of table 2 and table 3 and unify it and project it as one. So I say C underscore union underscore all with content of tab 2 and with content of tab 3, both will be consolidated as one result set, and then I'm just printing this result. That will be C underscore union underscore all. Yeah. So to do this, I get to see the result set from less than 10, result set greater than 110, both have been grouped as one. But in order to use this C underscore union operation, you must make sure the structure of tab 2 and tab 3 must be same. Next, about C underscore calc. We have another function C underscore calc. When you want to perform some calculations, simple calculations, we use this C underscore calc function. Um, so if you see this, I'm just trying to read this customer ID, net sales, quantity from this table and collect that into tab 2. Then I'm just collecting this tab 3 result by using this function C underscore projection, where I'm saying content of tab 2 and then project the columns customer ID, net sales and quantity. Apart from these three columns, I also want to project another column as average selling price, which will be with the calculation of say C underscore calc of where I'm going to do net sales divided by quantity and with this data type as integer as ASP. So this is the another column what I'm projecting out. Like this, you can use the C calc when you want to perform the calculations here. Yeah, and just printing the result of tab 3. So I just call this. That's numeric overflow, so not to worry on this. That's how you get this average selling price calculated. Yeah. So like this, you can use all the C functions and implement pretty much most of the logics. And if there's something you can't implement with the C functions, you have to go with implement it with normal SQL statements. But never implement a logic with the mix of both. Yeah. Next, we'll get on to using currency conversions.
Sir, I have a question, sir.
Yeah.
Sir, it seems like CE underscore column table, you can access the data of a column table
Yeah.
as well as the attribute, the column view of an attribute view as well.
No, if you want to read, access the column view of an attribute, then you have to use C underscore join underscore view, right? C underscore column underscore table is a function to read data from a column store table. But when you want to read data from a attribute view, column view of an attribute view, then you have to use C underscore join underscore view. I told the other day, right? If you want to read data from a column view of an analytical view, then C underscore overlap underscore view. When you want to read from the catalog calculation view, then it is C underscore calc underscore view. Yeah. Did I answer your question or was it something else? You all are able to hear me, right? Any issues?
Sorry, I was talking on mute. Sir, Nano C underscore column table function uses C. I was trying to access, by mistake, I was trying to access the attribute view, column view, and I was able to retrieve the data. And this C column table was working for column view, attribute view also.
Oh, you mean to
So
say,
my question was,
C underscore column underscore table was able to read data from column view also. That's what you're saying.
attribute view only, not analytic view or calculation view, only from attribute view. I was able to retrieve data. Yes, sir.
Means attribute view means how did you read? Means was it the column view of an attribute view or direct attribute?
Yes. Column view or the attribute view. Yes, sir.
See, in the column view, attribute view will be normal, but when you see there is something here, you should know. One second, I'll show you. We are referring to column views, right? Within this column views, you will have lots of types again. You see, you'll see, if you see this, you see this symbol here, like a calculator here, yeah? That is called, all these are column views, but there is a difference in this. You see this calculator symbol that represents calculation catalog column view. This is a catalog object and a column view. We refer it as calculation catalog column view. Yeah? But if I go to something like analytical view, you see this orange symbol. This indicates overlap catalog column view. Yeah. If you go with something like attribute view, see, if you go to attribute view, these are not like calculation views. These are not like overlap calculation view or overlap catalog view. These are like normal calculation column views. You see this for attribute? That's where you're able to read. But when you go to analytical view or when you go to your calculation view, there are special type of column views. One is overlap catalog column view. One is calculation catalog column view. Yeah. Since these are of normal type, you're able to read them. Yeah. Okay.
Okay, sir.
Because I'll tell you one thing. If you one more thing for you, if I just say, look at this. If I say select star from this is what? This is just normal column view of attribute view, right? I can do this. I'm able to read, right? Yeah. But if I say AB, it will not allow you, see, if I say select star from some analytical view, yeah, column view. Now I'm trying to put a select star from and trying to read from the overlap catalog column view. Now let's see what does this say. See, aggregation and grouping is necessary because since this is overlap catalog column view, whenever you read it needs to be specified with the aggregation function for the measures. That is one. If I try to pick some calculation column view,
This is the same error I got, sir.
yeah. That's what, these are the different types. We need to specify aggregation functions. This does not have any measures, that's fine. But if it has got measures, you have to specify clearly when you read from overlap or calculation column view, you should say sum of the measure and group by what. Otherwise, you will not be able to read. That's where we need to go with those functions. C underscore overlap underscore view. Yeah.
Thank you, sir.
Yeah. Next one is about currency conversion. And currency conversion is pretty much, the logic of currency conversion is pretty much same like a BW, where it actually considers the source currency, target currency, and the exchange rates. And as we know, exchange rates keep differing from currency to currency and time to time. So how do we do this in BW? Before we perform the currency conversion as a prerequisite, you go about maintaining all the currency conversion relevant tables like for currency codes, you'll have T-cur C and then T-cur for exchange rates, T-cur X, T-cur F for factors, the number of days, all this. There will be a lot of standard tables in the backend which maintains the information about those currencies. And then you leverage those tables and perform the unit conversion, right? Similar way, even in HANA, in order to perform the conversion, in order to perform the currency conversion, we need to make sure we have those tables available. Yeah. Okay. So what I have done is I have a schema called SAP underscore HANA underscore demo. In this schema, so in order to perform currency conversion, I had already replicated those tables relevant to currency conversion. Look at this. T-cur C, T-cur F, T-cur N, T-cur T, T-cur V, T-cur W, T-cur X. All these tables relevant to currency conversion, I've already replicated and kept them ready. Yeah. So when I use this functions currency conversion, the system automatically checks for the tables with the naming as tker C, tker F, tker N bus. But here my table names are completely different. So what I've done is, in the same schema, I've created a synonym saying tker C is referring to this table name and tker F is referring to this table name, and I've created a synonyms like this. So now I can use this particular schema. Since I'm able to have the tables with these naming, I can refer to this schema for the conversion. Yeah. Now this is how it is. I want this 9 cubex SQL. I would say. What I'm doing is I'm just creating some table and then inserting 2 records first. I am calling the table as sample input. This is my table. So my table gives me the 2 rows. I've got source currency, target currency, and I've got some date of relevance, and I've got amount. I would like to convert these values, price values, from source currency to target currency based on referring to these dates. Yeah. Okay. So we have in the SQL we have a normal function to do this. We'll just select convert currency and we specify all these parameters into it. See, and then you'll have first parameter as amount. Which column do you would like to refer that as amount, which is nothing price. The source unit column. From this table, what is my source unit column? This is the one, right, which is nothing but source unit. From this table, which column should I refer it as source unit? Source unit is my source unit column. Then schema. In which schema do I have all my currency relevant tables? Then I gave it as what? SAP underscore HANA underscore demo. From this schema, it'll refer to those tables. And then target underscore unit underscore column. And I would like to say this is my target underscore unit is a column for it. So I would pass in target underscore unit. Reference date, I'm not taking the reference date from the table because those are old. I know the values are maintained for this date because in my tker table, exchange rates are specific to these dates. And error handling, if it's not able to convert anything, set it to blank. And currency conversion type, if you see this, I'm going with historical rate. Yeah. Let me just say. Let's see if you see this tker table. In this, it has got a field called mandate where all the records are with 000. And I've got source currency, target currency, and I'm referring to this exchange rates 1003, which is the historical rate. I would like to use this euros to USD. Yeah. So I would say currency conversion type I would like to use is 1003. And do we have the normally that is a client dependent table, so it'll have exchange rates maintained with respect to each client. So I would like to refer the records where my client is 000. Yeah. And I'm referring all this and what are the result I'm going to get is with this function currency conversion. I would like to project that as converted value from, I'm reading all this columns from which table? Sample input. You get this converted value as this. If you want to see even the original values, you will say what? You want to see the converted value. Then you also wanted to see all this 4 also, right? You want to see the price. Then you want to see what was the source unit. What was the target unit, and all this would be from the same table. So you get to see the 1000 was converted as 940 and 2000 is converted as 1880. So like this, you can also perform currency conversion. This is a normal SQL function. This is not CE function. This is a normal SQL function convert currency. Same way we can also use the C function, C underscore conversion for currency conversions or unit conversion. So only for currency conversion. Yeah.
Hello.
Hello, yeah.
Sir, we have different source system, right? And different source system, they are maintaining different tables and different field sets. So initially, we need to create in HANA table, in HANA database, T curves, whatever you are shown, right?
Yeah,
That tables we need to replicate from.
exactly, exactly. So what I have done is, if you see, that's what I was saying. Yes. Please mute yourself, boss. Yes, let's say I have this schema, SAP underscore HANA underscore demo, right? And I showed you some tables here. You're not worried now how I would have replicated these tables from different source. It could be Oracle or SAP or whatever it is. And here the table names what I replicate would be completely different. But my HANA engine, when it has to do currency conversion, it expects to see the tables with this naming, T-cur, T. So what I've done, I've actually created synonyms for those tables with this expected naming by the engines. So now my system is able to leverage these tables, and when I specify this schema, you'll refer to the tables of this schema in this and then perform the conversion. You understand this right now?
Yes, sir.
Yes. And that is the best example or scenario where you actually deal with synonyms.
Okay. You need to take SAP tables as a reference for remaining source table, or we can take any tables or sources for the. I mean, you have deployed as a T currency. Those tables are there in SAP, right? Not in
Exactly.
other source system, right?
Even HANA is also an SAP product, right? So it expects to see have the tables with the same naming. Let's say I'm replicating data from Oracle. Let's say they give the table name as exchange underscore rates. In
Okay.
that case, I'll have to create a synonym saying T-cur, create a synonym T-cur for exchange rate. So even though the table name is exchange rates, I must rename a synonym, create a synonym for that as T-cur. So that when I use this function convert underscore currency, it will leverage to those tables and do perform the conversion. Yeah? Because if you see this, here you never specified it has to pick this exchange rate from which table it is, right? You only specify the
Hmm.
schema. So from this schema, by default, it expects to see the table. Suppose if I give it as 9 cubic SQL, okay, yeah, and where I don't have any of the table with this naming, it says can't do. What did it say? So this could not read currency presence from the table. So what is what it said? T cur. What is it? See?
Invalid table.
Yeah, it is expecting to see a table called T cur X from that 9 cubic SQL. So, but TCorrect is an SAP relevant table. So HANA is also an SAP relevant system application, right? So that's where they've designed like that. So if I replicate this from currency relevant table from different source like Oracle or SQL Server or DB2, I'll have to make sure I create synonyms for the corresponding tables and make it ready. Otherwise, the system will not be able to recognize that. Yeah.
In that case, structure of different source system table structure need to be same, right? I mean,
Exactly.
if you are taking.
See, you have to manage it. Say, let's say there
Okay.
might be a single table which has got factors, exchange rates, everything into single table. Then
Okay.
you have to create a specific views which will project only those columns, or in the ETL part you have to transform it and make sure you split those tables in the required format. Then create a synonym for those tables and keep it ready to perform currency conversions. Yeah.
Okay. Yeah.
So
Got it.
that is where to that is where is not solving problem for every source. He's making it
Okay.
comfortable only for SAP customers so that they are pushed towards SAP applications. Yeah. Strategy. Okay. Now, we've seen the procedures pretty much, but now I would like to show you about functions. Okay, boss. First, let's see what is function. Then we'll get into the understanding difference between procedure and functions. See, in ABAP, we have got different type of ABAP programs you can create. You can create a function model, you can create an executable program, include a program, all this. Same way, we can implement SQL scripting either by using stored as a part of a stored procedure or as part of functions or as part of triggers. Okay. Now we've been writing scripting with stored procedures till now. Now we can also use the same to implement it as part of functions also. Now let me show you how do we write a function, then we'll see the difference. So I'm just creating a function here, a simple one. Something like say create. Now when you want to create a procedure, you say create procedure, but here it is function, so it's a create function, and this is the name of this schema, and this is the function name, and I've got two parameters. Look at this. Look at the point here. If it is procedure, do you how do you declare the input parameters in a procedure bus? You say in variable parameter name and then data type, right? And if you want an output parameter, you say out parameter name data type, or if you want in and out, then you say in out parameter name, right? But look at this. When I'm creating a function, am I using this keyword like in or out or something here? Did I use any keyword in or out bus? No, right? So it means whatever you declare here, by default, they are only input parameters. So your function can only have input parameters. It cannot have an output parameter. That's where we don't ever explicitly specify the using the keyword in here. What are the parameters you specify in those parentheses? By default, they're considered as input parameters because functions can only have input parameter, but it cannot have any output parameters. Okay. Then to declare output, we use this keyword returns and say what do you want to return from this function, v underscore c. I'm returning from my function after it performs all the logic. It has written a parameter was. And here it is it can return only one parameter alone, which is defined with returns. This is of type integer. Look at this. I'm returning a parameter called v underscore c, of which data type it is integer or varchar or normal data type. Those are called as scalar variable data types. So this is called as scalar functions. Functions which returns normal scalar variable data types, we call this normal scalar functions here. So I'm just taking the content of A and B, adding it and returning it as C. That's it. This is my function. Okay, now let me just call this. So I can call this function any way you want. Say select 9. See, I'm just calling it as like any other function what I had. Say now if you want concatenate, what do you say? Select concat of string 1, string 2. Same way. This is another function I would like to use, which is my built-in function. So select the function of this schema, pass on the values and collect the v underscore c. I can say as the result. Yeah. So like how we are calling a normal standard function, we're able to call our own functions like this. So normally if it is a procedure, let's say with the procedure, how do you call a procedure? You either write it as call, or if your procedure is returning a column v, then I can use that column v in the from class. But if you look at the function, I can use a function in the column projection list class. Yeah. If it is scalar function. Next, we'll go with a table UDF. Okay. We have a concept called table UDF where it's a table user defined function. It's a user defined.
Sir, one small question.
Yeah.
Yeah, when we try to display the content of the variable in a procedure, we use colon, right? Here we use dot in a function.
Here, right? You're
in
calling
query,
it.
you have referred to table.
Dot. See, you're referring. Yeah. You're calling it. See, I'm saying function which is this has been written by that. So v underscore c of this function. So this, I'm just passing the parameters to this function, collecting the return. So this is, I'm not using the call procedure here. I'm using this in the projection list of the column as a normal function. Yeah.
Okay, but here dot is mandatory, right? When we want to display the content of the output variable.
Now let me come to that. Yeah. Now look at this. Here it will change again. Say create function. A function name of the function what I want. 9-cube SQL return table. Okay. And I just have one parameter here. So whatever I specify the parameter, it is by default input parameter, which is a customer ID. LV underscore cust ID is going to be an input parameter. But in this case, after I take this input, I would like to return back, but I want to return back that as a table, not a single column. So I'm declaring the table structure here. So I would like to return back returns what? In this case, I'm saying return. I am explicitly using the keyword table. Previously, it was just saying return v underscore c, which is a normal scalar variable. But when I want to return certain set of rows, a result set, then I'll say returns table. And what is the structure of this table I want? So I would like to return the table with this structure: customer ID, city ID, name, so and so, so and so. This is the structure of the table what I'm returning as begin and end. So I would say start writing this. V and return select star from so and so where this customer ID is less than 20. So this result set is by default returned where the structure of this return type is declared with these columns. Okay. Now just say execute. Now this is a table UDF function, right? I can't say how do I call this now. We cannot use call. So I should say select star. You should understand the table UDF as another table itself. You should understand the table UDF function as if it's another row set, another table set. Yeah. Select star from this. Sorry. I was not using that, right? One second. Where customer ID is less than, I'll say. Let me do this. Let me use a parameter. Yeah? So select star from, look at this, I'm using this function as if it's another table, right? Of what was it? It needs a customer ID. So now I'll pass 20 from this. See now, look at this. When this function is called, it is going to return me rows, so like a table. And I'm just trying to read from this. So now I'm using this function in from clause of the select statement here. Yeah? So now I'm not using any dot. So it's not that you use dot always. It depends on the type of function. If it is scalar variable function, we are going to use, we cannot use it in the from clause because it is, in this case the function is just returning a single value variable. So I cannot use it in the from clause. It has to be used from in the column clause of the select statement. In that case, it has to be returned value must be referred to with the dot. But if the function is a table UDF, which is returning a set of rows, which is treated as a table, then this type of function will be present in the from clause of the select statement. You got the difference now? Yeah. But the logic what you write is pretty much same. You write the same kind of scripting again. Yeah. It's only about reading. Yeah. Tell me. Yeah.
You're just passing the value here. That's it.
That's it. You understand the difference between calling the normal scalar variable function with the dot and how is it I'm calling a table use a different function. Table is a different function. You can treat that as a normal table itself, but only the virtual on fly it reads that and gives you. Yeah.
Yeah. Thank you.
Okay, sir. When it comes to the customer table, say for example, it contains 12 columns.
Yeah.
And if we want to return a table with 8 columns, so will it be possible?
Yeah. Say for example here it will take time, but suppose I wanted to have only customer ID and city ID. Yeah? Then I take this out. Then instead of staying star, I'll say what? Select customer ID, comma, then you want what? City ID. Yeah. Now your function is going to return only these two columns here.
Okay. And so dot, as in the previous example, we have given this return character, that is v underscore c, dot v underscore c.
One sec.
It means that ideally we are.
One sec. Let me just. So now this is going to return only two columns now. Yeah. Now what is the next question? Yeah. Yeah.
I was saying that as in the previous example, we were returning the value of v underscore c, and we have just preceded a dot before it, that is we have written as v dot v underscore c. It means it is only for the scalar functions, right?
Exactly. See, there will be two types of functions. A function which is returning a normal variable of scalar data type. A function which is returning a set of rows. So the function which is returning a set of rows is what we refer to as table UDF, table user defined function, which is going to return table type. And if you have a table type function, it must be used in the from clause of the select statement like this. Yeah. If you got a scalar variable type function, it must be used in the column clause of the select statement. Here, look at this. I'm not using, I'm saying from dummy. I'm not using this in the from clause. I'm using this in the column list clause. But a table user defined function which is giving me result set, I'm using this as a normal table. Look at this. I'm using it from the from clause. Yeah.
Sir, here in the return select, the QX SQL dot customer is a different table, right? We are referring to.
Sorry, what is it? What is it?
Uh, After begin, there is a we are returning the table, right?
Yeah.
In the select statement.
Yeah.
In the select statement, we have used the schema QX SQL dot customer. That is another table which we are referring this customer ID and customer city ID, right?
Yeah, because I don't have my this table in my schema, so I'm referring it from different schema. Yeah.
Yeah. Okay. Yeah.
Yeah. You can refer from any schema. Okay. So knowing this, to be more understand the exact, you love this function types.
So one more down.
Yeah, yeah.
Yeah, when we are returning a table, can we refer the structure to the previous existing table?
When we are referring
We're
to,
declaring a structure.
sorry, what is it?
Hello.
Yeah, yeah,
Yeah, we are referring a structure, right?
yeah,
Yeah, customer ID and city ID.
yeah,
Can we take it from the previous existing table, the structure
yeah,
function?
yeah. See, let's say I want the table written as not this is customer and city. Okay, but the columns what I'm reading from a table are different, and I just have to say as, because we don't have a concept like into corresponding fields, so we should use this as. This is what you're asking, right, or anything else?
No. I am asking that మనము ఇక్కడ రిటర్న్ టేబుల్ ఉంది కదా, ప్రీవియస్ ఎగ్జిస్టింగ్ టేబుల్ స్ట్రక్చర్ రిఫర్ చేసుకోవచ్చా డైరెక్ట్ గా మీన్ టేబుల్ నేమ్?
Oh, you mean to say instead of referring the columns, can we declare with the table type? That's what you're saying.
Yeah.
No, no. We have to declare the columns here.
No. Okay, thank you.
Let me just try. I don't think it is possible. Let's see once. So the purpose of table type is for declarations only. Table. But that is only for procedure, not we cannot use. Let me just try. ID name salary something. I don't know. I was referring from which table is it? ID, name, salary. Okay, what was my structure? Tax value. I can just put something. 9 cubics employee. Let's try this. Here it is ID, name, salary, SLA, SALA, and here it is SLA, SLARAY. Okay. Then I will say ID. I'm okay with this. Then this name, SLARAY. That's a different name. Then there's no tax well. Then I'm just trying to put some constant as tax well. Start at 03. And that's now let's see. Says cannot execute this return stable syntax error near dot. No. See, it is not expecting this. Okay, let me remove this and say set schema and then try doing this. I don't think so. No, boss. It is not accepting the table type definitions here. You have to declare those columns explicitly. Yeah?
Okay. Thank you. Thank you.
If I have this table employee and ID integer varchar 20 10.2. Name varchar of 20. The next was SLARAY decimal 10 of 2. There's one more. I'm okay with those 3 columns. So now I've declared this. Sorry. This parameter does not satisfy this. Now if you say 03, now it works out. Okay, I cannot use a table type definitions. Okay. Now look at this. They say there are 2 kinds of user-defined functions. User-defined function is like, say, there will be standard functions delivered by system, and UDF is like you're defining your own functions. Now within this user-defined functions, there will be 2 types. One is the table user-defined table UDF, which is and scalar UDF functions. Okay, table UDF and scalar UDF also. Okay, if it is table user-defined function, it is going to return a table, and normal scalar UDF is going to return a normal scalar variable data types here. Okay. Now let's see the actual difference between the procedures and functions. So now I'm able to implement the logic of scripting or SQL scripting either by using a procedure or a function, right? So now we'll have to understand the difference now between a procedure and a function. Now very, very important. procedure can return 0 or n values, whereas function can return one value which is mandatory. Very, very, very important. See, can you build a stored procedure where it is not returning anything? Yes. Can you have a stored procedure where it returns out multiple output parameters? Yes. But whereas function, it has to return and it can return only one value. Okay. That's the difference. Then procedures can have input and output parameters for which, whereas functions can only have input parameters. If you remember the parameters, what you specify, in the procedure you use a keyword in, out and in, out and differentiate input and output parameters. But whereas when it comes to function, it can only have input parameters here. Okay? And the next statement is very, very important. Procedure allows select as well as DML. Even at the runtime of the stored procedure, I can use DML statements, but whereas it allows, means like I can use select, insert, delete, update, all this. But whereas your procedure function would allow only to read, which is only select statement alone. Yeah. And we use a call statement. Functions can call the procedures, but whereas procedures cannot be called by functions. Because within the function, I cannot say call procedure, but inside a procedure, I can say select star from some function where as if I'm reading from a table. Yes. So we can call functions inside a procedure, but not procedures cannot be called inside a function. And exception handling can be done in procedure, but whereas we cannot do the try catch block in the function. Okay, we can only do that in procedures. And we can also do a transaction management in the procedures, like say committing, rollback, all this in this, but functions we cannot do. And next is procedures, and the procedures we cannot utilize them in the select statement. You have to call them with the call function, call procedure name. But whereas user-defined functions, you can use them into the select statement, either from the column list or the from class. Can be used in the SQL statements anywhere in the having, where, select, whereas stored procedures cannot be. And UDF that return tables can be treated as another row set or another table, and we can also use it to join to another tables also. So take the, see, you should treat the table UDF as another table itself, another object which is giving you multiple rows. We can use it like reading from a table. I can use it like something like joining also. Anywhere you can use it. So that's the difference between your procedure and function. So when you're able to implement your logic either by functions or procedures, so these points come in, which where you decide whether you got to go with the function or go with the procedure. Yeah. And the it's pretty much same logic.
Sir, both are reusable components, right? I mean, procedure as well as functions. I mean, once you declare the procedure, that procedure can reusable to other schema like that. Is it?
That's what there's a point there we can reuse, but only thing is we cannot use procedures inside a function, but a function can be used in procedure. Okay.
Okay.
Next, there is another concept. History enabled sessions. Very good concept. We're going to deal with something called history session enabled tables. When I say history session enabled tables, simple it will be, you can refer it as time dependent master data or slowly changing dimensions, or we can refer to something like time traveling queries. Okay. Let's say there is certain column values which keeps changing throughout the date and time. Then you want to give them the snapshot what it was on a particular timing. Yeah? Then you go with history enabled session tables. You understand the concept? While creating a tables, you can create the tables with session type as history. So when do we use that? Basically, when you, let me just, okay. So when you want to implement the concept of time-dependent data or time-dependent master data or slowly changing dimensions, or when you want to implement some snapshotting scenarios, you would require to store the value of with specific to date and time, and then based on the date and time when you're doing reporting, you would like to show different set of values in the reporting. That's where we use history session enabled tables. Yeah. Now just try to understand this. See how that I'm doing? Just opening SQL editor, and I'm trying to switch off this auto commit off. So that I would like to do commit whenever I want, so that I can gather the timing when the commit was done. So auto commit is switched off. It's very simple, but conceptually you should understand this. Okay, I'm just trying to drop. There's a table already. There's no table, fine. Now look at this. I'm just trying to create a small table with ID, name, and city. But I'm just using extra keyword here as histories. So create, apart from the keyword, create column table, so and so. But I'm creating this column table with session type as history bus. We call it a session type, yeah. Okay. Now let me just do this. Let me take out this. Let me show you actual difference between. System is getting stuck. It is disconnected, I think. It is trying to connect back. Okay. Just try to understand this. Say I'm trying to remove this keyword history bus, and what are this does this become like normal table bus? Yeah, just select this and normal table, right? Just activate, and let me show you one difference. Select star from m underscore cs underscore all underscore. This is a standard tag view which gives a list of columns where underscore name is equal to your 9 cubex SQL, and table underscore name is equal to what? This is a table you created. Look at this. Very, very important. You actually created this table called test history so and so as a normal column table with 3 columns: ID, name, and city. So apart from the columns what you specified, by default there will be 2 columns internally stored. One is the, I told you about row ID, and there will be one more column called Trex UDIV. Like for each column it just generates one Trex ID unit, which is for different purpose. We are not worried on that. And there will be something called row ID bus. Okay. Now let's see this. let me delete this table. Again, I'm going to create this with this keyword word. Now I'm going to create a table with session, a column store table with session type as history bus. Yeah, just select this and say activate. And now let's see the internal structure of this table. What columns are coming? There will be two columns extra. One is, look at this, row ID and so on. So, but there's two columns, valid from and valid to. Remember, this does this look similar to your time dependent master data with valid date, date from and date to, something like that? It holds two extra columns. One is valid from and valid to. But these valid from and valid to are not the dates. It holds the commit IDs. Let's say I create one record and perform a commit. It says this record is valid from this commit to this commit, so and so. When I do a change, again it maintains another record with the change saying valid from this commit. So for each commit wise, it maintains those changes with using these two internal columns, but we don't get to see them. But internally there will be two columns, valid from and valid to. Let me show you that. Okay. And one more thing is, I told you there's a standard table called tables where you can see the information about the table. But if you see this table, you get to see that this table, what was my table? 9 cubex SQL. This table is created with what session type? What is this here? It says type of table is column and session type is history bus. Yeah. Okay, I'll show you. Now look at this now. Very try to understand this. First, I'm just trying to insert 3 records into this, saying 101 as my employee ID and some name is Pratap and Hyderabad. But look at this person Chandu who says 1001. He belongs to Hyderabad now, right? Yeah. I will say insert this and perform a commit and update the delta merge. Yeah. Let's just do this. And let's see what was the last commit ID, because every time you perform a commit, it performs on commit ID, right? I would like to see what was the last commit ID number. Remember this? Let me just hold this out into a notepad and keep it. So these 3 records were inserted with this commit ID. Okay, 336111154, and based on the commit ID, we can find out the timing when this was executed. Yeah. I just want to get the timing of it. This is a timestamp. Okay. Now this is a timestamp of the commit. Okay. Now let's go to the table and see how the data is maintained now. I would like to see all the columns of this table along with this hidden columns. One is valid from and valid to. We can also see those column values when you use this parameter saying request flag all rows. Yeah. All the change in rows, everything can be seen. Let me see that. See, it clearly says employed in ID name city. Okay. Now look at this valid from. What is this valid from filled with what? With the time, with the commit ID. And valid to is what? They have been valid after this date and time of this commit. They are valid continuously. Yeah. Now let me change one record. Now let's say this person Chandu has moved from Hyderabad to Bangalore bus. So then there will be an update statement which says set city is equal to Bangalore where ID equal to so and so. I'm updating and performing a commit again after some time. The last commit was with the system timing is something around 2:16. 1 minute and I enter the video. Let me just do this. Okay. Again, I performed a commit after the update, and this will have latest commit ID now. What is this commit ID? 336111216. This is the first change data, the second change. Now for this commit ID, I also want to know the timing. When was this commit performed? I can know that so this is a 218 and the previous change was a 216. Now can I say he was in Hyderabad from this time 216 to 218. After this 218 he was in Bangalore bus, right? Now let's see that. Again, if I go and see the table contents with valid from and valid to completely, it maintains a complete history of the changes. So it will have like 103 Chandu Bangalore. From previous commit ID is closed now. From 336115154 is valid from 33611 From this commit ID, to this commit ID is valid to Hyderabad, and from 216 is been valid for what? Bangalore. And for each commit ID, it will be associated with the timestamp. Yeah. Now, how do we see the exact date? Now, I'll say, now look at this. I can do two things when I'm reading data from history enabled tables. I can say as of unit, as of timestamp, and as of commit ID. Either ways, I can say. Whenever reading data from a history enabled tables, you can read data either by saying as of timestamp or as of commit ID to read the latest values. Yeah. Now look at this. What I say. Now first thing I'll say select star from so and so as of let's say I would say as of this second commit ID. Yeah. Which is 336111216. So as of this commit ID, where is he in? Yeah, he was in Bangalore, right? So now for Chand, it shows as what? Bangalore. But if I say 154, as of this commit ID 154, it shows me as Hyderabad. So like this, by using commit ID, you can read the history of the values. But generally, no user would remember the commit IDs, right? You would never know what commit was done, ID was done. So generally, they go with the timestamp. Yeah. 15th September 1st. Okay. September is like 8. So 01 and the timing was 218 something. Anything greater 219 I would give in. If I read as part of this timing, it will show it as
09 or 08.
so if it is anything greater than 2617, which is the timestamp, sorry 218, it will give you as Bangalore. But if I try to see the table with the timestamp something before to say 216 something, from 216 to 218, this will show 21838, 216. I can also say 17 because from 16 to 18 it is all that. So it will show it as Hyderabad. But if I try to see the result with 18, then it starts showing you as still Hyderabad because the second was on 1857. This query was run as 1828 seconds. From if I just give 59, from then onwards it will be what? It will show as Bangalore. So like this, you can maintain. This is called as history enabled sessions tables. We'll see how do we use them in the modeling. But when you want to define some time travel queries or time different master data or time different slowly changing dimension values, you go with history enabled sessions. History enabled session tables, and to define that we just use a keyword history Then in the backend, it automatically creates a table with 2 extra columns valid from valid to, where it maintains the commit IDs. From those commit IDs, it links up to the commit master data and then knows the timestamp of the transactions, and then enables to work with slowly changing dimensions. Okay. Any doubt?
Sir, this select statement at line number 54.
Line number 54. Yeah.
This request flag is equal to all rows. What does it mean?
See, actually, if I just see, I'll do one thing. If I just say select star from this table, yeah, like normal select, it will show only the latest change. It will not show the history of it.
Okay.
It's just showing only Bangalore, yeah. I wanted you to understand this by seeing all the history of changes. That's why I'm saying request flag all rows. Show me all the changed rows and the old row, everything to be shown.
Okay. And so one more thing. You have said that select star from select star dollar valid from and dollar valid to.
Uh-huh.
So when we are select,
So
okay.
these are the hidden
And why
columns.
aren't we able to?
These are the hidden columns. I told hidden columns, yeah.
So why aren't we able to see row ID dollar and that the other field, the extra column?
Sorry, I didn't understand. Row, you can see if you want. I just was printing what is required. Row ID, then you want a dollar.
Okay, got it. It's okay now.
So you get the row ID also. Okay. Okay.
Yes.
So I'll stop, and I think pretty much we're done with scripting. And from tomorrow we should start getting with the graphical modeling from tomorrow. So when you say graphical modeling, we're going to deal with the HANA modeling content about attribute view, analytical view, and calculation view. I think many people are with perception that that is easy, but that is the most complex one. Because if it is scripting, you have flexibility of writing any logic with the code. But when it gets into graphical modeling, you have to leverage the existing options and implement the logic. That is where it is tough. Yeah? So tomorrow we'll start with the graphical modeling.
Sir, in that case, can we expect the recordings today?
See, the problem with sending out recording is I am here, I'm in a secure network. I'm not able to access the internet. Okay. But I'll try it today. I'll try sending this out. Yeah. Okay. Today, I should be free
Okay.
today. I'll be sending. Okay? And I'm sorry for not having classes previously because I was busy with something else. Now I'm free. I'll have in regular classes. Okay. And I'm sorry for it. Okay. Fine. Thank you. Boss. We'll meet tomorrow. Yeah.
Thank you.